Okay, in this video, we're going to start in section 3.3, and we're going to talk about logarithmic phenomena. Okay, so first we're going to give the definition of a common logarithm. So a common logarithm, or log, or as we all know it as log, of a positive number, let's call it x, is written as log of x. Okay, what does that mean? It means is the power which 10 must be raised to in order to equal x. So how do we say that? Let's write the formula as log base A of B equal x. This means A to the power what equals B. The power x equals B. Now, in this section, we're going to be talking as A to be 10. Anytime you see log of x like this with no base, it means log of, there's the invisible 10 down here. So, we're gonna rewrite this to be log B equals x. Remember, anytime you see that, there's the imaginary 10 down here, but we don't write it. So I'm just gonna erase it for now. We say, so 10 to the power what in this case? So we say 10 this guy to the power x equals B. Okay, so 10 to the power x equals B. So let's take an example. If I say log base 10 of 10 equals x, you will ask yourself, 10, remember it's this 10 to the power what gives us 10? Well, this is 10 to the power 1. So in this case, x equals 1. Let me give you another one. Log of 100 equals x. I'll say, so 10 to the power what equals 100. We know 100 is 10 to the power 2. So in this case, x equals 2, and so on. Okay, now we know what the basic definition or the basic way to do log of base 10. Next, we're going to talk about the Richter scale. The Richter scale is used to measure the magnitude of earthquake. Used to measure the magnitude of earthquakes. Okay, so that when we are talking about the magnitude of earthquakes, there's two, excuse me, there is two things we're gonna talk about. The relative intensity and the magnitude. So we're gonna say, what is the relative intensity? The relative intensity of the earthquake is the measurement of the ground movement. So when we hear like about the earthquake, we hear about the ground movement. So the relative intensity is the measurement of the ground movement. Whereas the magnitude of the earthquake is the logarithm of the relative intensity, is the log of the relative intensity, and I'm going to abbreviate it in RI. So remember, you know when you've heard where it says the earthquake has a magnitude of 2.9 or 5.6 or 6.9 on the Richter scale. So the magnitude, the formula that we're going to be using is the magnitude equals log of the relative intensity. Or if I want to switch it around, remember this is magnitude equals log of relative intensity, or if I want to find the relative intensity, I will use the formula 10 to the power of the magnitude. Okay, so let's solve some problems on this. So for example, we have a earthquake of magnitude 5.9 on the Richter scale. Magnitude, I gave you the magnitude. Find the relative intensity, or the relative intensity of the earthquake is, let me give you an example. Let's solve an example. If an earthquake has a relative intensity, and I'm going to abbreviate it by RI, of let's say 8,300, find its magnitude. Well, the magnitude equals log of the relative intensity, which is log of 8,300. And we do that on the calculator, it'll be 3.919 and so on. But the magnitude is also always rounded to one decimal place. So the magnitude will be 3.9. Okay, simple as that. If I were to do, I'll give you the magnitude. Let's say the magnitude was 3.4. Find me the relative intensity. Well, okay, what's the formula? The magnitude equals, go back here, the log of the relative intensity. So 3.4 equals log, let's call it X. And remember what I said earlier, log of X equals B. In this case, the B is 3.4. So we'll say 10 to the power X equals 3.4. Oh, I'm sorry, not 10 to the power X, 10 to the power 3.4, my bad, equals X. So what's 10 to the power 4 is let me see again. 10 to the power, if I do 10 to the power 3.4 is not 335, it's 2511.89. So that's how I figured my X, which is my relative intensity. So it's just basic calculations. And we'll solve some more problems like that in the during class. So a little note that I want to mention here that if we say, let's say I have two earthquakes, earthquake A and earthquake B. Okay, this earthquake A was 3.5, had a measurement of 3.5 on the Richter scale. The other one had a measurement of 4.5. So we will say, like, if I want to compare them, well, looking at them, it's 1 point away. There's a 1 point difference because 4.5 minus 3.5 equals 1. An increase of 1 unit on the Richter scale would mean an increase in the relative intensity, by a factor of 10. So that means in here, it's 1 point or 1 unit means the earthquake B was 10 times as much, had the relative intensity as earthquake A. Whereas an increase of T units, let's just call it T units, would mean an increase in the relative intensity by a factor of 10 to the power T. So let's say right here, instead of 1, we had 3, or let's say we had 5 points difference. So it will be 10 to the power 5 times, which is 1, 4, 5. So 100,000 times different, times as much as earthquake A. That's how much an increase in the relative intensity. So earthquake B would be that much more intense than earthquake A. Okay. Next, we're going to be talking about the decibel ratings. So the decibel as a measurement of sound. So what is a decibel? The decibel rating of sound is 10 times the logarithm of the relative intensity. So if you want to write it, it will be decibels equals 10 log of the relative intensity. Or if I want to say the relative intensity equals 10 to the power 0.1 times decibel. Okay, so these are like basic formulas. You don't need to memorize them. You will have them with you, but this is what we're going to be, solving problems based on. So this one, if I want to rewrite this on the calculator, I will do 10 to the power 0.1. I can rewrite it as the relative intensity equals 1.26 decibels. Okay, and usually the decibels is given as this one has to be written as a whole number. So let me give you an example. I can add a picture here. Oops. Let me try to put it here. Okay, so for example, let's look at this guy right here. The first one I would say, okay, the decimal equals, what was the decimal again? 10 times the log of Ri. So 10 times log of the relative intensity of 1. Remember, log of 1 is 0. So 10 times 0 would be 0. And that's why we got 0 right here. Let me try for the rustling leaves. Decimal equals 10 times log of, what's my relative intensity? 10. 10, log 10 of base 10 is 1. So 10 times 1 is 10. And that's why I got 10 right here. And so on. Now, these are all the sounds that, we can measure by decibels. So if we keep going and you plug all this in the formula, you will get this much in decibel. Okay, so so the final formula, I would say that the relative intensity is 1.26 to the power decibel. And again, if I put decibel equal 1, if my decibel equal 1, and I plug it in here, then I'll get the relative intensity equals 1.26. This tells me that an increase in 1 decibel, so the kind of what we made, our final result is that if we increase, and that's my way of writing, an increase of 1 decibel multiplies the relative intensity by 1.26, as we saw up here. And then an increase of T decibels, I want to put it to the power T, multiplies the relative intensity by 1.26 to the power T. And that would be our general formula. Okay? So just like we had other examples, if I want to give an example right here, let's say I'm comparing sound A and sound B. And this one has, let's say, 75 decibels. Sound of 75 decibels. This one has 80 decibels. And we are comparing them. We say that is 5 decibel difference. So an increase of 5 decibel difference, we put it right here, means that 1.26 to the power 5, which is about 3.2. So we'd say that object B is about 3.2 times as much as intense as object A. Okay, because it was 5. So 1.25 to the power 5 is 3.2 times more intense than object A. Okay, so that is pretty much it for this part. Moving on, we're just gonna mention just a few more things. Solving exponential equations. When we are solving exponential equation, there is some logarithmic rules. So solving exponential equations. I want to say 4 rules, 3 logarithmic rules. The first rule would be log of a to the power t. I would bring the t down, so it will equal to t times log of a. The second one would be log of a times b. When we multiply, who is the same as multiplying is adding log a plus log b. Remember, these are all of base 10. And the third one, log of a over b. And who's the same as dividing? It is the negative or subtracting log a minus log b. And I just want to restate one of the old from last section. When we have a size n or a population of size n is equal to the initial value times 1 plus the rate to the power t. Remember that from the previous section for exponential growth? Well, we're going to be using it in this section again. So let's do an example. Okay, an example. Let's say we have a population that was originally 400. Originally means initial. And the growth rate, it's growing at a rate of 0.4%. How long would it take? So let's see, how long would it take to reach the population to reach, let's say 600, to reach 600? Well, let's go ahead and apply the formula. We know that our n is the initial value, which is 400, times 1 plus the rate, which is 0.4%. So 0.004 to the power t, rewriting it as 400 times 1.004 to the power t. And now what's our n in this case? Because it was given as 600. So let's solve for t. We divide this whole thing by 400, divide this whole thing by 400. We get 600 divided by 400 is 1.5 equals 1.004 to the power t. Now, look at this guy right here. And let's look at our first one up here. When we have a number to the power t, the way I say it is log both sides. You know how you sometimes multiply both sides by 2, or whatever you do to the left-hand side, you do to the right-hand side. The way I like to phrase it, I say log both sides. And when you log both sides, you get log of 1.5 equals log of 1.004 to the power t. And applying rule 1, I bring the t down. So now I have log of 1.5 equals t times log of 1.004. Now, one thing I want you to remember that this is a number. You can just plug it into the calculator. And this is a number. Also, you can plug it into the calculator. So divide both sides by log 1.004. Log. So I'll get t equals log of 1.5 over log of 1.004, which would give me 101.57. And since we're talking about time in this question, I think it was like months. So the time is 101.57 once. You see? And that's how we find the answer. So the general formula would be T equals log of A over log of B, when A equals B to the power T. Just log both sides and apply the formula. Okay. The next, and I want to say final thing we're going to be talking about is when we are doubling time or more. Let's say doubling time and more. Again, just a basic formula that you will be using is that suppose we have a quantity that grows exponentially and with a given base. So as we said right here, time is log of A over log of B. Well, if it's doubling, okay, that's a special case. So we'll have T equals, let's call it the general form, log of K over log of some kind of base. That's the general form. Now, if it's doubling, our K equals 2. So when we say we are doubling the time, so if they say they ask you, you have something that's growing, when would this double in time? So you will say T equals log of 2 over log whatever base we have. And we'll definitely solve some problems like that. For example, let's say you are given, suppose you have something, an investment, you're investing in something, and you're investing in house, okay? And in houses, and your growth is growing by 5%. You're having a growth of 5% each year. Okay, how long would it take for the investment to double in value? How long to double in value? Okay, well, let's see. Doubling in time would equal to the log of 2 over log of base. And what's my base here? Well, I know it's 5% increase. So log of 2 over log of, that's right, 1.05, because my base is 1, which is 100%, and I'm increasing it by 5%. And we'll put that in the calculator and we'll find out. Let's see, what's log of 2 divided by log of 1.05? It will be 14.2. So after 14.2, let's see, each year. So 14.2 years, my investment would double. So the same formula, we're gonna use it, whether it's doubling, and the other one, we're talking about the half-life. Remember when we talked about the half-life? Let's say we took the carbon 14 had a half-life of 5,770 years. And we said, let's find out after or when how long ago did let's say tree or this carbon item, this carbon element, how long, let me write that, how long ago did the carbon 14, it's called carbon 14, die, let's say. Okay, given the half-life of 5,770 and given we have a base of half, okay, they gave us the base of half, and if we have the original as 1/8, okay, the original amount that we started out was 1/8 of the original amount. So the exact same thing we used for the doubling formula. This is the base formula that we always use in order to find time. So again, we say, okay, time would be equals to log of k over log of base, which is, what's my log of k? What was my original amount? 1/8 log of 1/8 over, what's my base? Half, log of half. So we'll do log of 1/8 by log of half, which is equal to 3. So the time it took is 3, but 3 what? 3 half lives, because we're talking again here about having an element that has a half-life. Anytime you have a half-life, so we're talking about 3 half-lives, which would be 3 times 5,770, which would be 17,310 years. So 17,310 years ago, this item ceased to exist. That's pretty much it. In this section, it's really simple. There's just like 3 or 4 formulas that you just have to use and solve problems based on these formulas. And again, the formulas, you can have them with you and just solve basic math. This summarizes section 3.3. So now you should be able to solve the homework for section 3.3 on WebAssign.